When you have a device that shoots an object, the way that it works is that, say there might be some air that's going to take that object and it's going to apply a force on it and push it out. When it goes through the object, this is the distance that it's traveling. And so what we can do is define this. So when you have an object that has a force exerted on it and it's traveling a certain distance, the work can be written as force times displacement. We also know from the work-energy theorem that work can be written as the change in the kinetic energy. So we can rewrite this as work is kinetic energy final minus kinetic energy initial, and then work equals 1/2 m velocity final squared minus 1/2 m velocity initial squared. So next what we can do is, now that we have two different definitions of work, we can take the two equations and equal them to each other. So we can write force times displacement equals 1/2 mass times velocity final squared minus 1/2 mass times velocity initial squared. And then let's just go ahead and write out what we know. So force, that is actually our unknown and what we're solving for. And its units are going to be in Newton. Displacement is right here, 42.1 centimeters. And because our units are going to be newtons, we actually need to convert our centimeters to 0.421 meters. The reason being that the units of newtons is kilograms meters per second squared. So now we know that our mass is 15 grams. And again, in order to work in terms of newtons, we need to convert that to kilograms. Velocity initial, so the object is going to start at 0 meters per second. And then we're given in the problem that the final velocity is 924 meters per second. So now all we have to do is plug and chug. So force times 0.421 equals 1/2 0.015 924 squared minus 1/2 0.015 squared. So the units over here for D is m, the mass is kilograms, and the velocity squared is meters squared per second squared. So let's just track our units as well. So what we will get is force times 0.421 equals 6,403.32 minus 0. Now we just need to divide both sides of the equation, and we get force equals 15209.8. And just tracking our units, this was meters, this was kilograms, meters squared per second squared. So you can cancel out the meters, and we're left with kilograms times meter per second squared, also newtons. So that there is our final answer. Hey, if you made it here, please like and subscribe. That helps me know that you're finding these videos helpful, so then I can keep posting more. Thank you.